Hello everyone, welcome to College Algebra Lecture 12. So this lecture is going to be on linear functions. It's going to cover section 4.1 from the textbook. So we've talked about functions in general. Now we're going to get a little more specific and talk about linear functions. And then later in the course we'll talk about quadratic functions and then more general polynomial functions and then trigonometric functions. And maybe if we have time, we'll get into exponential and log functions. Okay, so linear functions. Let me define what a linear function is. And this is probably something that you guys are fairly familiar with, maybe more familiar than some other topics. So in equation form, the linear function is y equals mx plus b. So it's called the slope-intercept form. You can think of it as a slope-intercept form of a line, right? It's a linear function, so it represents the equation of a line. So it's a slope-intercept form, I'll say, of a line. Okay, let me fix that. Using function notation, then we can write it like this. It's f of x, so instead of y, we call f of x equals mx plus b. Now remember what the m and b stand for, right? The m is the slope, which we can also interpret, at least in terms of applied problems, as being the constant rate of change. So say is the slope or constant rate of change. And then the b is the initial or starting value basically when x is equal to 0, right? When the input is 0, the output is going to be b. So when x is equal to 0, that's what I mean by the initial starting value. The other way that you guys know b, and if I write it, you really want to be careful here, I want to write it as an ordered pair of point, 0 comma b is the y-intercept, right? Sometimes we say b is the y-intercept, but if you're being really careful, remember the y-intercept is actually a point, so it's really 0 comma b is the y-intercept. Okay, how do we know whether a linear function is increasing or decreasing? So increasing and decreasing linear functions. So if you have a linear function, right, f of x equals mx plus b, the way that we determine whether it's increasing or decreasing is by looking at the slope, right? So if the slope is positive, if it's greater than 0, then the function is increasing. If the slope is negative, so if it's less than 0, it's decreasing. And then if the slope is equal to 0, then the function is constant. Right, so the three cases are this, right? Let me draw this quickly. I could have, let's say this is my linear function. So one case could be like this, right? That would be increasing. This would be a case where the function is decreasing, right? So it has a negative slope. Let me draw it a little better. So positive slope, negative slope. And then the third case is if it's 0, then I'm just going to get y equals b, and that's going to be a constant function, right? It's going to be a horizontal line. Okay, how do we calculate slope? So we talked a little bit about this in a previous section, but let me just review this. So remember again, m is equal to the slope, right, or the rate of change. So we can think of m as being the ratio of the change in the output over the change in input. So it's change in output over change in input. So I can write that in several different ways, right? I could write it as delta y over delta x. I could also write it as y2 minus y1 over x2 minus x1. Or if I want to use function notation, I could write this as f of x2 minus f of x1 divided by x2 minus x1. Okay, and again, in terms of a graph, you can also think of it as rise over run. Right? These all mean the same thing. So let's do a straightforward example. Let's say we're asked to find the slope of the line that passes through let's say the point -2, 15 and 14, -15. So 14, -15. Okay, so how do I do that? Well, first of all, I have to label these ordered pairs. I have to label these points. So I'm going to call the first one x1, y1, and the second one x2, y2. Now I can simply plug into the slope formula, right? The slope is going to be y2 minus y1 over x2 minus x1. So this will be -15 minus 15 over 14 minus a -2. And then if we work this out, right, a -15 minus 15 is -30. 14 minus -2 is the same as 14 plus 2, so that's going to be 16. And then I can simplify that. 2 goes into both of them, right? So I can write this as -15 over 8. Right? So I took out a factor of 2 over 2. So that would be my answer. So the slope is -15 over 8. So if you were to graph this line, it would be decreasing, right? As you read left to right, it'd be decreasing. Okay, here's another example. Okay, so in this example, it says, on a bicycle, Autumn rides for 5 hours and is 32 miles from her house. After riding 7 hours, she is 44 miles away. what is her average speed? And by that, they mean the average speed over those last 2 hours, from 5 hours to 7 hours. Okay, so first thing, I have to remind you of what speed is and how to calculate speed. Remember, speed is equal to distance divided by time. So to really answer this question, you can think of it as the distance is like the change in position. So I'll call this like D2 minus D1. That would be her change in position, divided by T2 minus T1. So what is T1 D1, T2 D2? Well, if we look at the information in the problem, right, we know that at 5 hours, her position is 32 miles from the house. So you can think of this as like T1, D1. And then at 7 hours, she's 44 miles from the house. So this is like T2, D2. Right? So the distance, which is a change in position, is going to be 44 minus 32 over, and then the change in time is 7 minus 5. So this is equal to 12 divided by 2, which is 6. And remember, it has units, right, of miles per hour. So her average speed over that time interval from 5 to 7 hours is 6 miles per hour. Okay, what if we're given some information and we want to find the linear function, right? We want to find the equation of that line. How do we do that? Well, there's a couple of ways we can do that. One way is the following. So I'll say to find the linear equation, we can use this formula. Y minus y1 is equal to m times x minus x1. Okay, this is called the point slope formula of a line. Right, you need to know the slope m, and you need to know a point x1, y1. The other way we can do this, or we could just use the slope-intercept form, so the one that we already talked about, y equals mx plus b, and then we could figure out what m and b are, right? And then that would also give us the equation of a line. So both are fine. So let's look at some examples where we use these two ideas. So let's say we're told if f of x is a linear function, let's say we're told f of negative 1 equals 1 and f of 1 equals negative 2. Let's say we want to find the function now, f of x. Right? We want to find that equation. Okay, so if I'm told that f of negative 1 equals 1, my input is negative 1, my output is 1, right? So this is like basically telling me the point that the line passes through is negative 1, comma 1. And then the second condition, f of 1 equals negative 2, is like telling me the point 1, negative 2 is a point on that line, right? A point that the line passes through. So I can label these as x1, y1, x2, y2, right? So let's use that first the first equation, the point slope form of a line, to figure out the equation of a line. So the first thing I need to do is compute the slope, right? So I know the slope is going to be y2 minus y1 over x2 minus x1. So this will be negative 2 minus 1 over 1 minus a negative 1. Well, the numerator is going to be negative 3, right? Denominator would be positive 2. So that's my slope. So negative 3/2 would be my slope. So now I can plug in to that. Remember the slope point slope form is y minus y1 equals m times x minus x1. Doesn't matter which point I use. Doesn't matter. Since I already labeled the first one the 1s, let's just use that one. So I have y minus y1, but that's equal to 1, right? That comes from here. And that's got to equal negative 3/2. That's my slope. X is my variable, minus, and then x1 is negative 1. Okay, so this is the same as y minus 1 equals negative 3/2, and this is x, and then minus a negative 1 is the same as plus 1. I can distribute the negative 3/2, so I have negative 3/2 times x, and then negative 3/2 times positive 1 is minus 3/2. And then finally, I would need to add 1 to both sides, right? So I'll do it over here. I have negative 3/2 plus 1. But the lowest common denominator is 2, so I need to rewrite that 1. You can think of 1 as 1 over 1. So to get a 2 in the denominator, I need to multiply by 2 over 2. So this would be negative 3/2 plus 2/2, right? 2/2 is another way of writing 1. And then this is simply going to be negative 1/2. So that means y is going to equal negative 3/2 x minus 1/2. And that's my answer, right? Or you could write it as a function, right? I could say instead of y, I could call it f of x. Negative 3/2 x minus 1/2. Okay, the other way that you could do this see if I can squeeze it in down here. Other method. Assume we want our answer to fit the form y equals mx plus b. Right? That's how we wrote the final answer anyways, and that's typically how you want to write the final answer in the slope-intercept form. So I already know the slope, right? We calculated the slope earlier. The slope is equal to negative 3/2. So I plug that in. Where I have m, I want to plug in negative 3/2. Now, I need to figure out b, right? Once I figure out b, I'm done. I have the entire equation. So how do I figure out b? Well, since I know that those 2 points lie on the line, they have to satisfy the equation. So I can plug in one of those points and solve the equation for b. So I'm going to use the point, it was, what was it, negative 1, 1, right? I'm going to use the point negative 1, 1. So I'm going to plug in that point. So where I have a y, I put in a 1. Where I have an x, I put in a negative 1. So this is now saying 1 is equal to, well, negative 3/2 times negative 1 is positive 3/2 plus b. Now I just have to solve for b, right? So how do I solve for b? Well, I need to subtract 3/2 from both sides. So b is going to be 1 minus 3/2, but that's the same as 2/2 minus 3/2, which is equal to negative 1/2. So now I'm done, right? Now that I have the slope and now that I have b, I have my equation. So the equation now is going to be y equals negative 3/2 x minus 1/2. And again, you could write it as a function. You could write it as f of x equals negative 3/2 x minus 1/2. So either way, you could use the point slope formula or you could use the slope intercept form. Whatever way you feel more comfortable with is fine. Okay, the next example, we want to find the equation of the line given the graph of the line. Okay, so let's say we're given this graph and we want to find the equation of that line. Well, there's a couple of ways you could do this, right? One way is to look at look at like some points that are on the line, and probably the x and y intercepts will be the easiest in this case. So I know that point, right, 0, 3 is exactly on the line. And then I know the point right here, the x-intercept 5, 0 is on that line. So once I have that information, I could use those 2 points to find the equation of a line, right? This would be very similar to what we did in the previous question. I could calculate the slope, right? If you call one of these x1, y1, and then say x2, y2, then I know that the slope is going to be y2 minus y1 over x2 minus x1. So this is going to be 0 minus 3 over 5 minus 0. So this will be negative 3/5. And then I could either use the point slope form of a line or the slope intercept form, right? It doesn't really matter. Let me just see. I'll use the point slope form. So y minus y1 equals m times x minus x1. So in this case, I have, let me use this as my point. So I'll use the 0, 3 as my x1, y1. And I already have it actually labeled x1, y1. So this will be y minus 3 equals negative 3/5 x minus 0, right, which is just x. And then all I need to do is add 3 to both sides. And I have what I want. Y equals negative 3/5 x plus 3. So that's the equation of a line. Okay, another way you could have done this is you could have looked at the slope as being the rise over run. So if I start at this point right here, how do I get back in the line? Well, I'd have to move down 3 units. So my rise would be a negative 3. And then I had to move over to the right 5 units. And then I'm back on the line, right? So my run would be a positive 5. So the rise would be negative 3. The run would be a positive 5. And I already know, since I know the y-intercept, I know that that 3 is actually equal to my b. So then I could just plug into my y equals mx plus b formula, right? M was negative 3/5, and then the b was positive 3. So either way will give you it, right? There's always multiple ways of solving these types of problems. Okay, what if I give you a function and we want to graph it? Well, that's just like any type of graphing problem, right? We could just make a little table and then plot some points. And if you want to do it really nicely, then you would just do it in Desmos. So let's say I want to graph this linear function. F of x is equal to negative 2/5 x minus 3. Okay, so let's make a table. So I have my x values, y values. Let's pick some reasonable values to plug in. Well, 1 is 0, right? 0 is always easy to plug in for x. So in this case, if I plug in 0, then I have f of 0, which is negative 2/5 times 0 minus 3. So this is just going to be negative 3, right? The y, remember, this is, you can also call this y. The f of x is also called y. If I plug in, say, since I have negative 2/5, let me use like maybe 5 as an input. So I'm going to have y is equal to negative 2/5 times 5, so the 5s will cancel, minus 3. And that's going to give me negative 2 minus 3, which is negative 5. And it may be negative 5. So I have y equals negative 2/5 times negative 5 minus 3. Well, this is going to be, what, the 5s will cancel again, so I have negative 2 times negative 1 is positive 2 minus 3, so it's negative 1. Negative 1. So let's plot those points. So I have 0, negative 3, which is here. 5, negative 5, so 5 down 5 is here. And then negative 5, negative 1 right here. So this graph is going to look like this. By the way, you only need 2 points to graph a line, but the third one is just as a check. So it'll look something like that. Okay, so all we did was create a table of values, and then we can plot using that table. Okay, let's do some more examples where we have to find the equation of the line. So find the equation of the line. Passing through the points negative 3, 7 and 3, negative 5. Okay, so again, I have to find the slope first, right? So let me just label these. I'll label the negative 3, 7 as x1, y1, and I'll label the 3, negative 5 as x2, y2. So the slope is going to be y2 minus y1 over x2 minus x1. Right, so this will be negative 12 over positive 6. So that's going to be a negative 2. So the slope is negative 2. Okay, now use one of your techniques, either the point slope form or the slope intercept form. I'll just use the slope intercept form for this particular example. So I know it has to have the form y equals mx plus b. I already know m, so I'm going to plug it in. It's negative 2. And now I need to find b. Well, I know that both of those points satisfy that equation, so I can plug one of them in and use it to calculate b, to find b. So let me just use the first one. So y is 7, where x is negative 3. So this is 7 is equal to 6 plus b. And then finally, I need to subtract 6 from both sides. So b is equal to 1. Okay, so my equation of the line must have been y equals negative 2x plus b, so plus 1. Again, or you could write it, if you want it as a function, then it's negative 2x, f of x equals negative 2x plus 1. Okay, another example. Find the x and y intercepts of the graph of negative 2x plus 2y equals negative 4, then graph it. Okay, so this again is a linear equation, right? So this is a linear equation. We could solve this for y if we wanted to, right? And then we call the f of x. We will see that it's a function. So it's a linear equation or a linear function. And in this case, I want to find the x and y intercepts and then graph. So we talked earlier, again, in a section way back, how to find the x and y intercepts. So remember, let me just review that. So to find the x-intercept, what you do is you set y equal to 0 and you solve for x. So in this case, I have negative 2x plus 2 times 0, right, where I have a y, I'm going to plug in 0, and I'm going to solve this for x. So negative 2x equals negative 4, divided by negative 2. So it looks like x is going to be positive 2, which means the x-intercept is the point 2, 0. Right? Remember, the intercept itself is a point. It's an ordered pair. And then to find the y-intercept, I do the exact opposite, right? I set x equal to 0, and I solve for y. So this would be negative 2 times 0 plus 2 times y equals negative 4. So I have 2y is equal to negative 4. I would divide by positive 2. I'm going to get y is equal to negative 2. So the point, the actual y-intercept, is going to be the point 0, negative 2. Okay, now to plot it, I can just use these 2 points, right? So let me bring up a nice Cartesian plane. Okay, so 2, 0 would be this point right here, right? And then 0, negative 2 would be this point right here. So this linear equation is going to look like this. Right? And of course, it goes on forever, right? It's a line. Okay, just a reminder, remember there were 2 special cases, right? Horizontal and vertical lines. So let me remind you about those. Okay, reminder. A horizontal line first of all, it's a function, right? It passes the vertical line test. And it has the equation f of x equals, and then usually we call that constant b, right? Remember, this is just a constant. Like f of x equals negative 2, or f of x equals 5, or f of x equals pi, whatever it may be. Or, of course, you could write this also as y equals b. A vertical line first of all is not a function. Right, it fails the vertical line test miserably. In fact, the one vertical line, the same vertical line, would pass through an infinite number of times, right? Remember, it can only pass through it once to be a function. And it has the equation. So remember, we can't write it as a function now, so we'll just call it an equation. And remember, it was x is equal to a constant, which we usually call a. Okay, so if I give you a horizontal line and vertical line, let's see if we can come up with the equation. Okay, so here's the example. On the left, I have a graph, right? It's a vertical line, or you can tell it's a vertical line, and I want to know the equation of that line. Well, the easiest way to tell this is if you look at all these coordinates here. So if you look at any of these coordinates, any point that lies on the line itself, it's always going to be negative 2, comma something, right? This point would be negative 2, negative 3. This point would be negative 2, comma 2, and so on. So the x value is always negative 2, and we know that a vertical line should have the formula x equals a constant. So the equation of that line would be x equals negative 2. Okay, and then over here, right? If you look at all these points, I'll just randomly pick a few points here. This is like -5, comma 3, right? And then -1, comma 3, and then 3, comma 3. So the y values is always going to be a 3, and we know for a horizontal line, right, it has the equation y equals a constant. So in this case, it's y is equal to 3. Or in this case, we could also write it as a function, f of x is equal to 3. Right? So really, the quick way of answering the question is just look at the intercept. Right? It's got to be x equals, and then whatever that x value is of the x-intercept. And this one's got to be y equals whatever that value is of the y-intercept. Okay, the next topic I want to talk about is parallel and perpendicular lines. So determining whether lines are parallel or perpendicular. Okay, so parallel lines, what do we know about parallel lines? They're lines that do not intersect, right? Parallel lines do not intersect. So if I have two functions, let's say f of x equals, I'll call it m1 for slope 1, x plus b1, and let's say I have g of x equals m2x plus b2, then how do I know if these are parallel? Well, they're going to be parallel if their slopes are the same, right? So if m1 equals m2, and then we should also say and the y-intercepts are different, so b1's got to not equal b2. Otherwise, it would be exactly the same line. Okay, so if the slopes are the same and the y-intercepts are different, then the two lines are parallel. And then perpendicular lines, what's special about them? They intersect at right angles, right? At 90-degree angles. So they intersect at right, by right I mean 90-degree angles. Okay, so actually I don't need a line there. Let me get rid of that. So how do I know if two lines are perpendicular? So again, if I have two functions, say f of x is equal to m1x plus b1 and g of x is equal to m2x plus b2, these are going to be perpendicular if, remember it's a test on the slopes, if I multiply the slopes, if I take the product of the two slopes, so m1 times m2, if I get -1, then I know that they're perpendicular. Or the other way of saying this, you could solve that equation for m2, and I could say if m2 is -1 over m1, then I also know that they're perpendicular, right? So if one slope is negative the reciprocal of the other slope, then the two lines are perpendicular. Okay, so for example, let's say we want to determine whether the two lines are parallel, perpendicular, or neither. Okay, so I'm given, let's say, negative 4x plus y is equal to negative 10, and then maybe this line, negative x minus 4y is equal to 11. So the easiest way to do this is to put both of them in the form y equals mx plus b. Put them in the slope-intercept form. So I'll say put both into the form y equals mx plus b. Why? Because then it's easy to pick out the slope, and really the test depends on that slope. Okay, so how do I do that? Well, I just solve the equations for y, right? So in this case, for that first line, I need to add 4x to both sides. So I'm going to get y is equal to 4x minus 10. In the second case, I'd have to add x to both sides to start, right? So I have negative 4y is equal to x plus 11. Then I would need to divide by negative 4. So I'm going to get y is equal to, I can write this as 1x over negative 4 plus 11 over negative 4, right? And then if we clean it up a little bit, I can further rewrite this as negative 1/4 x minus 11 fourths. Because a positive divided by negative is negative, right? So you can bring that negative up into the numerator, or you can even pull it out front. Okay, well, certainly, right? Certainly, these are not parallel, right? Because if I call this my line 1, the first one my line 1, then m1 is equal to 4, and m2 is equal to negative 1/4, right? That would be, so m1 is the slope from the first line, m2 is the slope from the second line. They're not equal, so they can't be parallel. So now I just need to check to see whether they're perpendicular. If that check doesn't work, then the best answer is neither. But let me check to see whether they're perpendicular. So to see whether they're perpendicular, I multiply m1 times m2. So I have 4 times negative 1/4. Well, that's going to be equal to, you can think of it like this. 4's cancel. That's just negative 1, right? And remember, that is the test to see whether the two lines are perpendicular. So that checks. So these two lines are perpendicular. And if you plot them, you'll see that they're going to intersect at a right angle. Okay. What if we're given some information and we want to write the equation of a line that's parallel to a given line or perpendicular to a given line? How would we do that? Let's do an example like that. So let's say we want to write the equation of a line parallel to the line y equals negative x plus 5 that passes through the point negative 8, 1. Okay, so if we look at the given line, right? If we look at the given line, y equals, well, it's already in a nice form, y equals mx plus b. This negative x I can write as negative 1x, right, plus b. So that says that the slope of this line is negative 1, right? If I want my line to be parallel to this given line, then I want my slope, I'll call my slope m2, I want it equal to m1. So my slope is also going to be negative 1. Now that I know what my slope is and I know a point that the line passes through, you could call this x1, y1 if you want. Then I can figure out the equation of my line, right? So again, you can do it two different ways. I could use this formula y minus y1 equals m times x minus x1, or I could just simply use y equals mx plus b, plug in m, and then use that point to find b, right? You can use either one. So if I do it, I'll do it both ways. So if I do it the first way, I have y minus y1, which is 1, equals the slope, which is -1, x minus a -8. So this is going to be y minus 1 equals -1 times x plus 8. Now I need to distribute that -1. So y minus 1 equals negative x minus 8. And then finally, I'd have to add 1 to both sides. So I have y equals -x minus 7. And that would be my equation that would be the equation of my line. That's parallel to that given line and passes at the point -8, 1. The other way you can solve it is using the slope-intercept form, right? So here, I already know my slope. Remember we found it was -1, so I plug it in. Then I use that point now, so the point -8, 1, to figure out what b is. So y was 1, x is -8. So 1 equals 8 plus b. And now if I subtract 8 from both sides, I'm going to get b is equal to -7. So now that I know m and b, I can just plug them in. M is -1 and then b was -7. So you're going to get exactly the same thing. I don't know, sometimes one method is easier than the other depending on the values, but they're both about the same, right? So use whatever one you feel more comfortable with. Okay, let's see. Oh, how about this? Write the equation of a line perpendicular to the line in the graph below. So I'll give you the graph in a second. That passes through the point -1, 2. Okay, so here's the graph of the given line. I want to find the equation of my new line, which is perpendicular to that line and passes through the point -1, 2. Okay, so actually, if you think about this, right, I want my line to pass through -1, 2, so that's this point right here, and somehow it has to be perpendicular to this line, right? It has to form a right angle. Okay, so the first thing I need to do is I need to find the slope of this given line, right? Well, we can see 2 points that lie in that line. Just the intercepts would be the easiest. See this point right here? So this is -2, 0. And this point right here is 0, -3. So if I call the first one, say, x1, y1, and the second one, say, x2, y2, let me find the slope. So the slope is going to be y2 minus y1 over x2 minus x1. So this will be -3 over +2. So -3/2. Okay, so this is like, I'll call this M1, right? This is the given slope. I want my line to be perpendicular. So what is the slope of my line, of this red line here? Well, it has to be the reciprocal of that slope, right? Remember, my slope must be -1 over M1. So it's -1 over negative 3 halves. You can think of this as negative 1 over 1 over negative 3 halves. To simplify fractions, I take the first fraction and I multiply by the reciprocal of the second. Right, so this is going to be positive 2/3. The quick way of getting that, by the way, is if you take the original slope and if you flip it and then change the sign, that will give you the correct new slope. Okay, so now I need to come up with the equation that has this slope, 2/3, and passes through the point, what was the point again? Negative 1, 2. All right, so now we're back to our usual problem, right? Remember, there's a bunch of ways I can do this. For this problem, let me just do it y equals mx plus b. So I know my slope is 2/3. Now I'm going to use that point, the negative 1, 2, to figure out what b is, right? Because I know it has to satisfy this equation because that point lies on this line. So where I have a y, I'll plug in 2. Where I have an x, I'll plug in negative 1. So then this is going to be 2 is equal to negative 2/3 plus b. And now I need to find b, right? So I need to add 2/3 to both sides. So what's 2 plus 2/3? Well, you can think of 2, so 2 plus 2/3. My lowest common denominator is 3, right? So I can fix this if I multiply by, oops. Go a little too quick there. So it's 2 over 1, right? I can fix it if I multiply by 3 over 3, right? Then I'll have the correct denominator. So this is going to be 6/3 plus 2/3, which is 8/3. So b is equal to 8/3. So that means my equation was y is equal to 2/3 x, and then plus b now is plus 8/3. So that would be the equation of a line that is perpendicular to that given line and passes through that point, negative 1, 2. All right, great. So that's it for section 4.1 on linear functions. So the next thing I want to do, the next section, is some applied problems using linear functions, right, and linear equations.